heard John Boothroyd's presentation. And you're back. Isn't that exciting? Why did you come back?
My teacher at URI.
You have to come back. All right, good. And you probably learned something, right? Did it scare you? Okay. Well, again, here's a man who needs no introduction, John Boothroyd, and his colleague here, Brian Oakley, who's going to also be probably engaging in some of the presentation as well as some of the question and answer. So, John, do you want us to turn that light on?
No.
Okay.
No, we spent a lot of time getting it turned off.
All right.
This is when I need 3 hands, and I only have 2 because Superstorm Sandy did this. This is a result of a broken hip the day after Sandy. Not a good thing. Okay. Oh yeah. I guess I have to point it at the machine. I'll give you this. There's 2 summaries. I'll give you this summary first. First of all, the glacial geology is the key to understanding the processes and products we're going to do because the place is glaciated. The storms are the most important driver in coastal change. Sea level rise is a secondary effect. They go together, but really it's storms. Shore face sediment transport is not well understood at present, and that's what we're going to really work on in this SAMP, one of the things. Future major storms combined with sea level rise are a large problem. Accelerated sea level rise, which is what David was asked about, resulting in inundation is also a very large potential problem. Now, the Rhode Island CRMC is planning for a 3 to 5 foot rise by 2100 and a 1.5 foot rise by 2050. And I'll see if I can illustrate that. This is just to show you. Here you are. Here's the edge of the ice sheet, 26,000 years ago. So you'd be under a few hundred meters of ice. The shoreline was way out here, down 120 meters, and so this was all open plain. Then the ice melted, and when you add water back to the ocean, it's called eustatic sea level rise. And so here is eustatic sea level. It's the blue line. The red line we won't worry about right now. That's another time. But anyway, so about 26,000 years ago, it started off. Sea level started off. Rise started off slowly because the ice didn't melt very much, and the ice edge was kind of thin. Then it picked up and melted quite rapidly. And right in here, there's things called meltwater pulses. And so what happened is somebody pulled the cork out of the bottle of the ice sheet that was here. It's called the Laurentide ice sheet. And sea level may have risen as much as 2 meters in 100 years or a half a meter in 10 years because of the downdraw of ice. And so this is going to be a problem for Greenland now. And those of you who have seen the video of chasing ice when the Greenland outlet glaciers are carving quite rapidly, that is a problem. We'll come back and talk about that in a moment. But anyway, here the sea level is rising 2 meters in 100 years, and by the time you get up here to now, it was rising tens of centimeters, a few tens of centimeters in 100 years. There's quite a bit of difference. We're going to talk about, see if we can do this. We're going to talk tonight just about this part right here in southern Rhode Island, what we're going to look at in the first year of the SAMP, and then we'll get to these other places. We're not going to ignore these things up here, but the rest of the talk is going to concentrate in some places. So, everybody has got to have a crashing wave picture, and boy, there's a lot of them. Everybody runs to the Narragansett Pier seawall. And so this is just to tell you that storms are the driver. Here is frontal erosion in at the Browning Cottages. This is a field trip in 2007. Brian's down here on the beach taking the picture, and the students are all freezing to death up here. It's in February and it's cold as hell. But the shoreline's going away. And so actually, by the time of Superstorm Sandy, the Browning Cottages were pretty much devastated. These coconut logs filled with sand were a soft structure attempt to protect, and they protected against moderate storms, but Sandy was too big. These are the things that we call burritos in Rhode Island. As David already talked about, Superstorm Sandy was a hybrid, and I'll show you a couple slides on that in a moment. And so even 2 days later, 2 days after Superstorm Sandy, there still was the hybrid extratropical nature, and so there was a large surge. And so here's a surge coming in at high tide at Brownings. Now here, what we've done in the past is we have measured on images and old aerial photographs the high tide mark, or the wet dry line. And here's where it was in '51. Here's where it is. We drew it on in 2012. We have received the money, and we're about to do this for using the 2011 aerial 2011 images, ortho images. It would be really helpful if we had a post-Sandy flight. So if any of you out there would like to give the SAMP some money, we're in need of a 2013 flight to bring these images up to date. But out here on the shore face, this is the part that's below mean low water. We have maps of some of the part of the shore face, not all the way out here, but we know there's a sand sheet out here, so when some sand erodes off the beach and comes back in a few weeks, it's out here in this yellow part. The blue part are old glacial deltas. Notice the gravel pavement here. We know the sand underneath this gravel pavement, but we don't know how much gravel you have to go through. These are big boulders, which is actually outcrop of glacial material. And then there are these cross-shore swaths where the sand is disappearing offshore somewhere. And so we don't know how much sand is out there and whether we can go out and grab it and perhaps bring some of it back. And so that will be a target of this sand. Okay, so here's a Sandy geologic summary. So what geologists would say, Sandy was a tropical, extratropical hybrid, as David already talked about. It's interesting, the Corps of Engineers has a buoy out in the outer Rhode Island Sound. It recorded a significant wave height of 31 feet at the inner shelf buoy. Significant wave height is the height of the highest 1/3 of the wave during any 20-minute period. It's 31 feet. This max recorded wave height of the raw data was 47 feet. Now this is what was thought, as David already pointed out. These are 1938 hurricane-sized waves. There were no buoys then to measure that, but that's what it was thought to be. Rhode Island received a glancing blow, a public misconception by some, and I've already heard this in meetings, believe it is a 100-year event. Oh, it must be a 100-year event. We don't have to worry about it for a while yet. And as David points out, you ain't seen nothing yet. The greatest geologic change and infrastructure damage since Hurricane Carol in 1954. And I'll show you some evidence of that. Geologic change is what we're looking at. Washover fan deposition is an underestimated problem. And I'll expand on that a little bit. So we need a shoreline change special area management plan to better prepare, and we already got started thanks to several of the people that were mentioned earlier. This David already showed this, but here is the blue is the predicted tide. The red is what actually happened, and the difference, the algebraic difference, is a storm surge. And so here's a surge, but as David pointed out, you see that the hybrid nature of the thing, there were 7 or 8 higher tides, and so you had such large waves, those waves were breaking, as you pointed out. Okay, here we are at the Newport tide gauge. This is the from mean low water to mean high water. Here's the Sandy water level, here's the Carol water level, and here's the 1938 hurricane water level. And so we have it 4.25 feet above mean high water. And we're using mean high water because people always ask, how high was it above high tide? And so that's why we're using mean high water. So these numbers might be a little bit different than somebody else's numbers. Suffice to say, this is what it would look like on a staff gauge. And so here's what it looks like plotted. This is Providence, elevation above mean high water. This is Newport, elevation above mean high water. Here is Tropical Storm Irene down here. Here's the blizzard of '78. This is Patriots Day. That's the perfect storm. There's Hurricane Bob, and there's Superstorm Sandy. So Superstorm Sandy was less in Providence, but more at Newport, above mean high water. And there's Hurricane Carol up here, and that's a 38 hurricane up there. So as David pointed out, it's around here, around a Hurricane Bob-sized surge. Okay, one of the things we do here is we actually go out in the field and measure a lot of stuff. And we've been doing that for 37 years, and the work is done by, in large part, by grad students. This is Scott Resolution right here, and undergraduates who are getting screen credits with this. But we use this method called 2 sticks in a string, or it's also called the modified Emery method after K.O. Emery of Woods Hole. And basically it's a simple geometric problem to look at the horizon, and you see the horizon right there, and it's the difference in elevation of the 2 sticks. So this is one of our profiles, and it goes right out here. And actually, it looks like it ends right there. This is washover fan deposition here. And there's this picture taken by Steve McCandless the day after. Here's what it looks like. This is pre-Sandy, 27 October. And here we are, post-Sandy, 30 October. And so all of this disappeared right here. And this was added, actually. That's the washover fan. Now, FEMA's dune protocol says this is what happened, and David also alluded to this. They say, okay, the dune went away. They don't say the beach also went away in the first few hours of the erosion or the erosional cycle. And so that means that the waves come in and break further inland and cause more damage further inland. So we just had a discussion about this, and where the Rhode Island CRMC and REMA and ourselves had a little discussion with FEMA about how they ought to maybe adapt this. We lost. Charleston Beach, this is what it looked like in the blizzard of '78 in this picture. This house has been moved back. This house is still there. It's heavily modified now. But this is 1978. And there we are. This is the blizzard of '78 in yellow, and that's post-Sandy in October 2012. So basically, we reset the clock after 30-some-odd years. And so all of the foredune zone that had built out here, and the berm that had built out in that intervening years, gone. Okay, now these are something that we're working on, and we'll work on this pretty extensively for the SAMP. This is an elevation difference diagram. The post-Sandy LIDAR with the USGS 2011 LIDAR. And so green is positive, stuff was deposited. Red is things are removed. And so this is the foredune, the whole foredune that was removed here. That's a vegetation line you see there. There's a 78 line back there. This is the elevation change of 2 to 3 meters of material was removed. A lot of this material went back here, but some went out there. Now, one of the problems that we're having is people come along immediately and take it away. And so, to us, they removed an alluvial, a washover fan. They moved up, but to them, they got rid of all the junk in the road. So, that is. That's an infrastructure. That is an infrastructure problem. Okay, now, in some places, though, it's really pretty to a geologist. This is pre-Sandy, Quantico barrier, conservation land, washover fan deposition of the little one here, and another little guy over here. And this is taken by Nate Bosquet's drone. Can't call it a drone yet, but that's what it is. But this is before And that's after. And there is a washover fan. And so we're pleading with the people down there not to do anything to this. They have to allow transport four-wheel drive vehicles across it, but don't mess it with it. This is a geologic antiquity. It's not an antiquity yet, but it's a geologic feature that needs to be preserved. This arrow points at the thing that looks like a scarp here. It's actually a soot face, and it tells you that the water in the lagoon was this high, and Pawnee Pond was this high when that was being deposited. And people have said, "But look, it's covering up the marsh. It's supposed to do that." That's what happens as the barriers evolve. This is a naturally evolving barrier. It's a beautiful thing to a geologist. Okay, so here's a very general coastal barrier model for Rhode Island. This is a barrier. You were looking at the washover fan about in that location right there. There's a four-dune zone. There's a house for scale. Here's a coastal lagoon back here and the Atlantic Ocean out here. And it's actually sitting on a bunch of silt right here, which was deposited in the lagoon. Now, then that has to tell you this barrier has gone all the way across and onto the sediment of the lagoon, and underneath is a glacial material. Okay, so we can look at that down in Napa Tree. And so here's the Napa Tree barrier, which is now mostly conservation land. Watch Hill right here, and we're going to look at this within this square right here. Here's a very busy slide that has the shoreline. This is a shoreline change map, and this is on the CRMC website. This is one of the ones we're going to be updating, but you can go to those. This tells you how much was eroded between 1939 and 2004. This tells you a rate, but we don't like the rate anymore because it just takes big jumps. So underneath here is the 39 ocean side, the 39 sound side. This is the 2004 ocean side and the 2004 sound side. Okay, here is where the barrier was in 1939. Here's where it was in 2004. It's basically eroded back one barrier width. And if you go out to Napa Tree, you will see dune grass paths. Not too much we're doing at the moment, but all the rosa rugosa and everything. And you said, this thing hasn't changed for tens of years. Yes, it has. This is what happens to the natural system. This is the natural system. Okay, here is a system, not very natural, but attempting to be so. So here is Atlantic Avenue, down in the Misquamicut barrier. Here's the washover pan, and Dave Valley showed this picture. By the way, RIDOT did all of the scientists in the state of service by flying in that helicopter the day after. And these pictures are quite remarkable pictures because a lot of them are there before humans, as John Stewart would say, mucked up the works. The geology, that is. Now, if you're worried about infrastructure, it's an entirely different story. So there has to be some accommodation between infrastructure and geology. So here we are after Hurricane Bob, and here's the bucket loader. And I'm saying to you that removal is a bad idea because the barriers are trying to naturally retreat landward and upward. And what that does, when you have this here, when the next overwash, water, and surge happens, the friction of the sand that's already there slows things down and is not nearly as bad, and it may not penetrate as far anymore. So, where possible, and I understand that in many cases this is not possible, but where possible, leave the sand there. Okay, now, here is deposition here and damage in Westerly. So here is the washover pan, here is the Andrea Hotel, and there we had a beach profile right there. We've since reestablished the profile, but it was actually on a post on a concrete slab. And here are the concrete slabs. They've been moved around a bit, so we lost the profile, but we reestablished it. But I use the Andrea as an example because here we are in sometime in the late 1950s to early 60s. This picture was provided to me. I wonder if the Providence Journal, anyway, that's a 1957 Ford. I was a car nut when I was in high school. That's the Andrea Hotel right there. Now this seemed like a good idea at the time because cars weigh a lot, they're big things, but cars are mostly air. And so if you think of a big rectangular block of granite the size of a car, what would be the weight of that block of granite versus the weight of this automobile? Automobiles are mostly air, it doesn't work. The automobiles are still there, by the way, all the parts thereof. Janet Friedman has some really neat pictures of this that I didn't have time to show tonight. Anyway, this was on a Sunday Journal front page above the fold. That's the Andrea being removed, and I would call this a managed retreat. Managed retreat because they're going to move it back and elevate it, rather than try to put everything back and build right on the same site. So that's a managed retreat. They didn't retreat very far, but they did retreat and elevate. And so that's part of the story. Here's a fate of washover fans at Misquamicut State Beach. Okay, now what do? Now we have all these piles of sand. Well, hopefully we're going to replenish the shoreline, and we're going to exercise scientific rationale when we do that. And there are ways to do that, which I'd be glad to discuss with people, but please do it scientifically rationally. Okay, so now a very brief look at climate change. I just put this in here to say that this is the sometimes called the ceiling curve. This is atmospheric CO2 at Mauna Loa Observatory. And there's 3 lines on here. This is when I came to Rhode Island in 1975. It was 330 parts per million. This is now, it's up here at 394. Going towards 400. And this right here is 350.org. How many people subscribe to 350.org? That's where it was in 1987. I don't think there's going to be much chance of it getting back to here. I'm having a little trouble even getting this curve to flatten out a little bit. So that's what it's about. Well, what does that do? Greenhouse gas warms the atmosphere, warms the ocean, melts the ice melts and goes into the ocean, and the sea level rises. Okay. So here is a historic sea level rise curve. This is monthly data from the Newport gauge, averaged into a year. So every data point is a year there, and then there's a regression line to it. So from 1930-ish up here to 2011, this shows it at 26.9 plus or minus 2.3 for 100 years. So it depends if you want to start here. It's 10 inches up there. I'm almost done. And this was a subject of a political thing. And where is mostly true, Janet? We had a little spat with Eugene Emery Jr. Anyway, okay. Here's that diagram. This is a historic curve right here, and if you carry that out like this, it would go out to there, and get to here in 2100. In 2050, it would get to here. And so this is what you have to do by law in North Carolina. You can't talk about this other stuff. Right here, this is the IPCC 2007 model average. This is the land ice with land ice in there. And this is Vermeer and Ramsdorff's various modeled curves. We here decided to follow this one right here. So there's 137 by 2100 and 41, or 1.4 feet and 4.5 feet. 1.4 feet by 2050 and 4.5 feet by 2100. I just came back from a geology meeting, and the plenary session was given by Tad Pfeffer, who is the IPCC lead author in charge of land ice and carving glaciers. And that's a problem they can't get their minds around, is this very dynamic carving aspect of particularly the Greenland outlet glaciers. And that might lead to a meltwater pulse. Remember the meltwater pulse in the first, way back when? Okay, so what do we got? We summarize out of that. Here we have what it looks like today. That's what it's going to look like with an inundation of 5 feet and 200 feet of barrier migration. So the barrier is freely migrating, and the lagoon is flooding up onto the backside. And so it's a big race between barrier migration backwards and lagoon flooding. But that's a lagoon, and that's an integrate in 2190. Now, what we're going to do is we're going to add a 1938 hurricane on top of that. And there are inundation depths. And so it inundates Route 1 right here, and it inundates all the way up to here. Okay, so how do we see this? You see this? This is South Kingstown, Town Beach. This is what it looked like in 2005. This is what it looks like in right after Hurricane Sandy. They're the boardwalk pilings. This is what happened in the intervening time when we went out there and did the field work in 96 to 2012, back 28 meters. And now we can project that into the future, which we're going to do for the SAMP. And here is the first one. That's a projected change. This is 1951, total distance, 1951 to 2012. So right there, for instance, 265 feet. Now, taking that same amount per year and doing it out to 2050, we get here. So here's the 2050 high tide line. Okay, thank you.